Good afternoon, ladies and gentlemen. Welcome to the international webinar on use of polymer to control extra produced water from an oil field, organized by Advanced Research Society for Science and Sociology in association with IRAJ Webinars. On the behalf of entire organizing committee, I'm Isaac Behra, organizing secretary. Would like to welcome you all for this webinar. Ladies and gentlemen, let me introduce our organization. The motto behind this non-profit association is to bridge the gap between students, professors, academics, and industrialists from multidiscipline. Apart from organizing various seminars, expert talks, and conferences, we have various highly rated multidisciplinary journals in the field of science, engineering, technology, and management. Since our inception, we have been arranged various international conferences at various parts of the world like New York, London, Australia, Hong Kong, Dubai, Bangkok, Kuala Lumpur, India, etc. More than 1 lakh research papers have been published during our journey, have been presented and published during our journey. Today, I'm glad to welcome you all as a member of this fastest growing network for the advancement of science and technology in terms of research and innovation. Today, we were very much fortunate to have an eminent professor and expert who is joining this webinar as an expert speaker and guest. His name is Professor Dr. Abdollah Esmaeili. Presently, he is working as a professor at Al-Farabi Kazakh National University, Almaty, Kazakhstan. Now I'd like to welcome our Professor Abdollah Esmaeili to deliver the webinar.
Thanks a lot. So, ladies and gentlemen, my colleagues, let me to start my presentation as the conference coordinators introduce me. I'm Abdollah Esmaeili. I'm here to present my presentation. The title is begin. Yeah, the title is use of polymer to control extra produced water from an oil field. At the beginning, you can see here that this is our policy, that we believe that no proposal is perfect, but every proposal is perfectible. So we expect you to help us to complete our proposals. So we are open for questions, for your advices, for your comments. And here is my connection and my mobile and WhatsApp numbers for any questions. Okay, so our main topics will be problem statement, research procedures, polymer and polymer gel, overview of gel treatment, properties of gel and gel, and finally some field operational issues. You know that not only in this research, but also in our total research, we have two main parts. First of all, we must know the problems, then we will try to solve. So each project, each research project will have two main parts. The first part, the problem, and knowing the problem and problem definition, and then finding a solution to solve it. So then we will try to solve it. Okay, as an introduction, as the rate of our discovering new reservoir decreases, you know that improve and enhanced oil recovery techniques are becoming increasingly important for major oil fields. So IOR and EOR process often involve the injection of material not present in the reservoir, such as polymer, such as foams, solvents, surfactants. So conformance control is a key IOR, improved oil recovery, and EOR, enhanced oil recovery method, and is defined as any technique that encourages movements of normal upstream, reminding oil and gas bring the driver closer to perfect conforming condition. So in order to achieve the preferred conforming condition and produce more oil and gas, water production must be minimized. Why? Since it becomes a major problem as hydrocarbon reservoir major. So it's our policy in production and petroleum engineering, in oil and gas engineering, that we say that when we produce from a hydrocarbon reservoir, we must try to produce only hydrocarbon, other fluids. So water as a non-hydrocarbon fluids must remain at the reservoir, must not be produced. Why? because of several reasons that we will talk about that in later slides. So, first of all, what is our problems? You know that nowadays extra produced water from oil and gas reservoir is one of the serious problems for industry and for our companies. So this is one of the most important factors which affect oil and gas production rate from producing that. But extra produced water from oil and gas reservoir can cause several problems. Operational cost increasing. Generally, we have two types of problems: technical and operational, economical. So if we produce a lot of water at surface in oil and gas reservoirs, we will have several operational and technical problems and economical problems. Imagine that we produce from an hydrocarbon reservoir, from an oil reservoir, from a crude reservoir, we produce 1 barrel of crude. If 80% of this barrel of crude be water, so actually we produce water, not oil. So we must minimize water production. Of course, when we produce oil, when we produce gas, some water will be produced as associated water with oil or with gas. But the amount of this produced water must not be exceed from a limitation. We must not have exceed production of water. So exceed production of water must be controlled. So why do we want to reduce water production? For these two main reasons: to reduce operational expenses and to increase carbon production. Okay, at a static condition, a reservoir in a static condition has something like this: gas oil contact, above water contact here. We will have a layer of oil here. This is a layer of oil. The above will be layer, gas layer here, water layer. So between gas and oil, we will have a gas oil contact. Between water and oil, we will have water oil contact. So water oil contact will be here, gas oil contact will be here, and oil will flow from the reservoir to the well bore and from the well bore to the well head from here. Normal condition and a static condition. But when we start to produce from the oil reservoir, so the oil column, the heights of oil column, the depths of oil column will be increased, will begin to be decreased. So at the bottom we will have water, at the top we will have gas. So gas oil contact and water oil contact will be shifted. Gas oil contact will move downward toward the down, and water oil contact will move toward the upward. And after several years, water will reach to our introducing interval. Here is oil introducing interval. From this introducing interval, we produce oil. So here is oil producing interval. And after several years of production, water will reach to this interval, production interval, and maybe bottom of this interval will be invaded completely by water. So in this case, we will say that we have water cooling. And the top of this interval may be invaded completely by gas. So in that case, we can say that we have gas cooling. Something like this, it's better for imagination. For water cooling, that water is flowed from the reservoir to the well bowl here, and the water will reach to introducing to the bottom, to the well bowl, to the here. will be produced as an associated with water. That's the best for our imagination that what will happen in reservoir. From here, we are producing oil. This is oil formation. From here, we will produce oil. The oil is producing from here. The oil is flow from reservoir to the wellbore through this producing interval to the wellbore and then flow to the wellhead. But you can imagine that what will happen in our bottom this interval. What will happen in this interval? Water cooling has been taking place here. Why? Because water formation are flowing from water layer into our oil producing interval. So this interval has completely been invaded by water. So water are producing through this interval to the wellbore and then to the wellhead as an associated water with oil. This slide is better slide for our better imagination that what will happen in reservoir. You can see that here is water well contact, initial water well contact, and after several years of production, this is the second water oil contact. So this interval has been invaded completely by water. Water might be produced through fractures. Through this fracture, water can flow to the wellbore and then from wellbore to the wellhead. If we have a fracture reservoir, if we have some fracture at the reservoir also, water can flow through this fracture to the wellbore. Here, fracture or fault. Totally causes of excess water production might be something like this. We have 4 main reasons for excess production of water, for excess water production. The first one is open water zone, like this. We might have an open water zone, so through this zone, we will produce water while we produce oil. Another possibility that flow behind pipe and casing leakage. We may have leakage behind the casing. So because of this leakage, water can flow to the producing interval, oil producing interval, and then to the surface. Or channeling from injector, like this, from fracture, for example. From fracture, through the fracture, water can flow through the fracture to the wellbore and then to the wellhead. Or water coning, as we discussed about that. Water, maybe we have water coning at the bottom of the producing interval, something like this, and then water can be produced. So this is our problem. So now we have a problem. What is the problem? Now we must find the solution. For the solution, we have 2 methods, 2 types of solutions: chemical solution and mechanical solution. In chemical solutions, we have several methods in chemical solutions, same as polymer gel injection. That is our topics for today's discussion. In mechanical solution, we may have packers and plugs. So in mechanical solution, but so in mechanical method, there are several methods to solve this problem, same as horizontal drilling, deviation drilling, using tubing in production passages of water, but had separation facilities. In horizontal and deviation drilling to solve this problem in mechanical methods, we might drill horizontally, we may drill by a deviation to be far from water zone, to don't have water coning. Or in perhaps separation facilities, at the worst case, we may have to increase the separation facility at the surface to be able to separate water from the oil. You know that we separate water from the oil by separate. If the amount of this water be increased, so we have to increase our separators from 1 to 2 separators, 3 separators, 4 separators. So our cost will be increased. So economically, it's not beneficial for us to produce a lot of water at the surface. So if we produce a lot of water, too much water at the surface, at the worst case, we have to increase our separators, our separation system to separate this too much water from oil. So the best case for us is to don't let a problem to be taken place. And at the worst case, if we cannot control the problem, and this problem has taken place, at the worst case, at the final step, we will think to how we can solve it. So at the first step, we must think to how we can prevent it. How we can prevent these problems not to be occur, not to be taken place. If we cannot control the condition and the problem be taken place, then we can search to find some method to solve it. So at the first step, we will try to solve the problem at the reservoir, not at the surface. So our topic today here is to inject polymer into the reservoir to solve the problem at the reservoir, not at the surface. Okay, chemical methods are cement, polymer gel, resin, foam, injection of this. So polymer gel, polymer injection is our topic today. We are going to discuss about it. Okay, see here in mechanical solution, using a plumb to shut off the production water, as you can see here. Through this interval, we have unwanted water production. You can see here that this is our reservoir. From here, we are producing oil from this formation, oil flow from the reservoir to the wellbore, and from the wellbore to the wellhead through this interval. But through this interval, we produce unwanted water production. We have unwanted water production through this interval because of water cooling. So we can install a plug like this, and this unwanted water cannot flow to the wellbore and then to the wellhead. So this water will be blocked. The pathway of this water will be blocked by this plug. Another solution is chemical solution. In chemical solution, one of the methods in chemical solution is to inject polymer gel. So polymer gel injection like this. We have several producing interval, the top, the intermediate, and the bottom. Here we have water cooling, and water is reaching to this producing interval, and to this interval, this water can be produced to the wellhead. And if we want to control it, we can control it by a gel layer like this. Polymer gel will be injected, and a gel layer here will be formed. A gel layer will be formed here, and this gel layer will be blocked. The water pathways, and water flow will be blocked, and water cannot flow from the reservoir, from water layer into the wellbore and then to the wellhead. So we can solve the problem by a gel layer. A gel layer will be stop water production. Okay, so objective of water shutoff treatment is water shutoff without seriously changing hydrocarbon productive zone. Yes, of course, we want to decrease water production, not to decrease hydrocarbon production. So we want to maximize blocking agent penetration into water source pathways while minimizing penetration into hydrocarbon pathways. Why? Because water productions must be blocked. Water production must be minimized, not hydrocarbon production. We want to increase hydrocarbon production. At the same time, we want to decrease water production. So water production must be minimized. We want to maximize permeability reduction in water source pathways while minimizing permeability reduction in hydrocarbon pathways. Yes, of course. We define permeability as the ability of the rock, reservoir rock, to let a fluid flow through it. If the permeability of a reservoir rock to water is minimum, so minimum water can flow through it. So water will stop at the reservoir and will not flow from the reservoir to the wellbore and then to the wellhead. So a little water will be produced. So in this case, if we can decrease water permeability or reservoir rock water permeability, the water production will be decreased. But water permeability, reservoir rock water permeability to oil must be maximized or its reduction must be minimized. Why? To have a lot of production of oil. We don't want to decrease oil production. We want to decrease water production. So reservoir rock permeability to oil must be high. And reservoir rock permeability to water or water reservoir rock permeability or water permeability must be minimized, must be decreased. So objective and scope of our research is to prevent extra production of water. There are several methods. Knowing the reason of extra production is, yes, of course, we have several methods. But knowing the reason of extra water production is the base, is our base to choose the best method to control it. So how we can, yes, of course, we say that we have several methods, but which one is better? So for this purpose, knowing the reason of extra production, water production is essential. Choosing the best method to control it. Okay, generally we have, as we discussed about it, we have two types of solution for this purpose: chemical and mechanical, as we discussed. Okay, so what will happen in this research? What will we do in this research? In this research, we will try to find a suitable polymer gel to prevent extra production, water production from an oil reservoir. So we must find a polymer gel which has a lot of effect of water permeability and a little effect of oil permeability. But for this purpose, we have a procedure, not only in this research, in our total research projects, we have procedures. In this research project, we will start first by focusing on characteristic of the reservoir and finally several steps. You know that not only in this research, but also in our total research, we have several steps. At the first step, we will have data gathering or data collecting or literature review at the first step to knowing the problems. Then at the second step, we may check our ideas, we may check our data, we may check our information by software, by computer. So at this step, we may have a modeling a simulation by software to check about what is the best method for solving the problems. At the third step, after modeling and simulation, we may have a laboratory test. So we may test our ideas at the laboratory and lab test. And then after lab test, we may have a pilot test in a small scale test. Imagine that we may consider to install a refinery. So we may check our test in a small pilot of a refinery. And then at the final step will be field test. So after if the total result is okay, so we may check our solutions, our methods in field as a field test. So field test is the final step. And after that, we can say that this solution is suitable for this field or for that field. Okay, here is a research table. So we start by primary study, literature review, then collecting existing information, checking preparation, the test, laboratory test, and then some analysis, and then reporting the data, writing the reports. Okay, so we found that one of the methods to solve this problem is chemical method, and in chemical method we selected polymer gel injection. But what is a polymer gel injection? Polymer gel injection is a process where polymer gel is injected into a reservoir to prevent extra production of water and to produce water. This process has been considered as a technique for produce water controlling, pushing the oil of the reservoir. Sorry. By injecting polymer gel with modified properties, the wetting properties will change toward a more water-wet reservoir wash. So by injecting polymer, we will try to change the wetting property toward a water-wet reservoir wash. Why? Because according to our definition, a water-wet reservoir will absorb water and will push the oil. If we have a reservoir and this reservoir absorbs water, so water will remain at the reservoir, will not produce at the surface. If we have a reservoir rock that this rock is water wet, it means that this rock will absorb water and will push the oil. It's exactly what we want. We want to don't have any production of water, and we want to have a low production of oil. If we have a reservoir that absorbs water and push oil, it means that water production will be minimized and oil production will be maximized. Okay, so yes, we know that polymer gel injection is a method, and maybe a best method based on the condition, on the condition of the reservoir and our operational and economical condition. But we have many, but what type of polymer? We have many polymer gel systems that has been developed based on the condition, on the temperature, on the ionic condition, on the pH, on the salinity, and other toxicity and other things. So we have several polymer systems. A polymer may be resistance to temperature change, the other may be resistance to pH change. So you know that when we talk about a reservoir, this reservoir is 4, 5, 6, 7 kilometers underground. So we are talking about 5 kilometers underground. 5 kilometers underground, 6 kilometers underground, the temperature and pressure there is very high. We are not at the surface. We will be at a reservoir, several kilometers underground. The pressure will be very high. The temperature will be very high. If we use a polymer, this polymer must be resistant to high temperature, to high pressure. Its properties must not be changed at high temperature and high pressure and at high salinity. You know that in reservoir we have a high salinity. So polymer used in the industry, generally we have two types of polymer in industry, synthetic polymer and biopolymers. Synthetic polymers are derived from petroleum, oil, and made by scientists and engineers. This is our definitions. Synthetic polymer are used for high temperature and acidities. They are mixed with appreciated cross linker, so polymer must be mixed with a cross linker to make a polymer gel. We will discuss about the cross linker later in our later slides. So example of synthetic polymer include same as nylon, same as polyethylene, same as polyester, same as Teflon, same as polyacrylamide. Here we select in our projects here. We selected polymer acrylamide as the polymer, as a suitable polymer. And we have biopolymers. Biopolymers are polymers that are produced by or derived from living organisms such as plants rather than from petroleum. So the primary source of biopolymers are renewable. Of course, the prefix bio means biodegradable material, and it means that they are produced by living organisms. Like xanthan is a biopolymer. Okay, so what about the cross-linker? Imagine that we have polymer, and this polymer will be mixed with cross-linker to make a gel, polymer gel. So we have gelate and we have gel. Gelate is polymer cross-linker solution before gel formation. Gel is cross-linking a structure of the reaction. So gelate are flowing, but gel will be stopped without flowing. So we add polymer and cross-linker to each other. A gelate will be formed. This gelate will flow into the reservoir, and after 1 hour, 2 hours, 3 hours, a gel, polymer gel will be formed, and this polymer gel layer will not be movable, will be stopped, and will block the water pathway. But what about the cross-linker? Cross-linker is an industry. Cross-linker causes the polymer gel to join together and to make a polymer gel. But cross-linker is divided into two categories, metallic and organic. Metal cross-linkers such as bronze, such as titanium, aluminum, such as chrome-3, for example. We use chrome-3 in our projects here. And organic cross-linkers such as phenylacetal and other phenyl and other polymers. So, at the beginning, we discussed about a little difference between polymer floating or polymer solution and polymer gel. There is a little difference between these two. Sometimes we inject polymer into the reservoir as a controlling agent to decrease the mobility of water and to increase the viscosity of water. So sometimes for a polymer float, polymer penetration into low K zones must be maximized. Why? Because in low K zones, we want to increase the viscosity of water and decrease its mobility. If mobility of water be decreased, So mobility of oil will be increased, so oil can flow easily. Here, for a gel treatment, gel penetration into low K zone should be minimized, but in high K zone must be maximal. Why? Because we produce most of our water production problems is from here, from high K zones. Why? Because in high K zone, water can flow easily and can be produced. So we blocked passageway of water from here in high K zone, that water cannot flow to the wellbore and then to the wellhead. So by polymer injection, we have two main ideas. Maybe we use polymer as a mobility control agent. In this case, when we use it as a mobility control agent, penetration into low K zone should be maximized. Sometimes we use polymer as a blocking agent. If we use polymer as a blocking agent, penetration into low K zones should be minimized, and penetration in high K zone should be maximized, because in this case we want to block the water. Okay, so this is the polymer flooding. That's the best method for improving the sweeps in the reservoir where fracture does not. And in polymer flooding, as I told you, we want to increase the water viscosity and decrease the water mobility. So water production will be decreased. In gel treatments are the best method for fracture and fracturate that cause channeling. Yeah. So in gel treatment, a gel layer will block the passageway of water. Okay, polymer flooding is an EOR method that uses polymer solution to increase oil recovery by decreasing water oil mobility ratio. Dear coordinator, what about the time? Sorry, what about the time?
Sir, 3 p.m., sir. 1 hour.
1 hour.
Yes, sir.
So, okay, so we have enough time, and we will summarize it to have some time, 10 minutes or around 10 minutes for question and answer section if our participants may they have questions. So I will go faster. Okay.
All right, sir. All right.
Yeah. Thanks a lot.
Thank you.
Okay. In polymer flooding, a water soluble polymer is added into the water flow, so this increases the viscosity of water. Okay. So basic properties of gel and gel. That this is we have several systems for gel and gel. We selected here chrome 3 as a cross-linker, polyacrylamide as a polymer. We added these two together to make a polymer gel system. But if we have several polymers, if we have several systems, so when we use this polymer, when we use that polymer, when we select this polymer, when we use that polymer, it's up to the cost, it's up to the several factors, cost, availability, others consideration. So here you can see what will be happen, gel versus gel, a polymer solution like hydroxypolymer acrylamide cross-linking like from 3 will be gel. In a gel, few cross-links have been made. So gel can flow into cross-rock just like uncross-linked polymer solution. So gel after some time, after 5 hours, 4 hours, 6 hours, will convert into a gel. Gel are 3-dimensional cross-link extraction that will not enter or flow through the cross-rock. So when a gel layer be formed, this gel layer will be stopped. Okay, like here, gel flow freely like a polymer solution into the reservoir. And this is, you can see partial gel formation after several times. And here, gel filling are aqueous for spaces after several times. Okay, so properties of available gelants, early ingelation process, gellant penetration really into post-rock. After gelation, gel penetration to post-rock is extremely slow and negligible. After gelation, we discussed about it. The transition between these two conditions is usually of short duration. Here you can see that this is a, we check the concentration of the effect of polymer or strength of the gel. Here, low gel strength, here intermediate gel strength, here strong gel strength. So when we increase the polymer, so the gel will be more stronger. And cross-linker. Here you can see that we have a viscous fluid. Here low gel strength and here a strong gel. Why? Because the cross-linker has been increased. Here cross-linker, we have a lot of cross-linker in this case. So if we increase the cross-linker, the gel will be more stronger, like here. If not, polymer gel cross-linker present, no gel will be poor. Then here we can check the viscosity with the time, viscosity versus time during gelation. And during this, so let me to go faster if you have enough time, if you have any questions. So here we check the time and the radius of the penetrations. Here we selected polyacrylamide, and after that we have the system. And we check our gelate system to the pH. If, as I told you, if we select the gel, this gel must be resistant to pH variation. We check that what will be happen if the pH has been changed. This is in polymer gel, but in polymer gel, we have several polymer gel system. In organic gels, and we discuss about that. Here we have some rises, but what types of acrylamide polymer we selected? For acrylamide polymer, first of all, we have non-ionic acrylamide. 2, hydrolyzed acrylamide. So if polymer acrylamide is the best polymer, we have several types of acrylamide. Which one is the best? So we check several acrylamide, non-ionic acrylamide, hydrolyzed acrylamide, sulfonated acrylamide, and hydrolyzed and sulfonated acrylamide together. So polymer acrylamide or HPAM polymers like this one, this is its structure. So we consider 5 groups of polymer to check. So to these steps, we know that polymer acrylamide is the best, but which one? This steps, this group, that group. So we consider 5 groups and we check these groups, and finally we will select this S groups. This group consists of 2 monomers, acrylamide and this one. This one, general structure of these groups. And then other groups, T groups. This is a terpolymer, which consists of acrylamide, sodium acrylamide, and 2-acrylamido, 2-methylpropane, sodium sulfonate. SO groups, another group. This is the SO group. And HPM groups, acrylamide and sodium acrylamide. And PAM group, this consists only of polyacrylamides. And this is the material used to produce this polymer gel. You can see here. This is our sample. So we provided several samples and we check total of them. And this is the results of our tests. So we provided several samples and check their viscosity versus times for this, you can see. at various shear stress, for example, at various shear stress versus time. Here you can see that we checked the time and viscosity for several acrylamide systems, and here we check the polymer concentration with gelation time. Yeah. For these types of polymers, for S4, for S6 group, for example. And here is formation water component, that this polymer must be suitable for this water, because this is our formation water at the reservoir. This is the effect of formation water or polymer gel that has been checked. And finally, this polymer has been selected, sulfonated acrylamide polymer for this reservoir. Maybe for another reservoir, another polymer will be suitable. So a sulfonated acrylamide polymer where 70% acrylamide and sulfonate 30% have been selected, but after that we check that if we increase the acrylamide to 75% and sulfonate decrease to 25%, this will be more stronger. So finally, this is our final choice. Here you can see, but okay, so now this is the best polymer. Now we are at the field test that how we can inject it into the reservoir. So this is our problems. We have water production. This is our treatment. So here we are going to treat it by gel, and here you can see that we treat it by gel. So gel has been blocked, this layer, and oil will be produced on it. And here you can see that we may have water production from here, but gel will be blocked with water layer and water will not produced. And this is our samples that we checked. This is our devices at the laboratory. The lab. This is cold flooding. We put our cores into these devices. This is core flooding. This is core flooding devices at the behind. This is core holder, our devices. This is viscositometers in library, and this is raw meters. And for filters, we have tanks like this and a pump, and then we'll inject into the wellhead, and then from wellhead into the wellbore and into the reservoir like this. We have some tank and chemical blending injection skid, and we will have a coil tubing, and through this coil tubing, the polymer will be injected into the reservoir like this. We have a mixing tank here. This has been connected to this injection pump has been connected to this coil tubing unit, and by this coil tubing, the polymer will be injected into the water layer to block the water pathways. Okay, and finally, for your kind more information, that a part of our previous research related to this topic was accepted for presentation in International Sustainable Producing Summit Interval as in Cancun in Mexico. Here is their acceptance letters. A part of our recent research related to this topic has been published in Journal of Advanced Chemical Engineering, and this is their confirmation letter. Thanks a lot, and if you have any question, you can email me or you can connect me by mobile and WhatsApp number. This is my mobile and WhatsApp numbers. Thanks a lot. Any question? Thank you so much. Any question? Any question?
I think there will be no questions, Professor.
Okay.
All right. Thank you, Professor, for sharing your valuable time and for joining this webinar. On the behalf of organizing committee ARSSS and IRAJ Webinars, I would like to present a certificate of appreciation to you, sir. Kindly accept it.
Thanks a lot. Thank you so much.
I would like to thank all our sponsors and coordinators. I'd also thank our president. We're happy to hear your comments and compliments or suggestion at our Facebook and Twitter page. This video will be available shortly in our YouTube channel. Kindly subscribe our official YouTube channel, IRAJ Conferences and Seminars, for all past and upcoming webinars and expert lectures. Thank you all. See you on another webinar soon. Thank you, Professor, for sharing your valuable time
Thank you, Bob.
and for joining
Thanks
this
a lot,
webinar.
Mike. Thank you so much. Thank you.
Thank you.